So then again, what is difference between scale up and scale out? What is difference between scale up and scale out? Okay. So scale up, we already discussed, right? Scale up is like increasing warehouse size. Scale out is adding the clusters. So use what? Increasing warehouse size. Small to medium, medium to large. And the scale out is adding the clusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So these things, okay. Scale up means increase the warehouse size. Warehouse, for example, going from medium to large. This gives more compute power for single complex query and reduces its execution time. Suppose the query taking longer time. Okay, in that scenario, we need to increase the warehouse size. Okay, scale up means increasing the size of the warehouse. For example, going from medium to large. This gives more compute power for a single complex query and reduces its execution time. Suppose if the query is taking 20 minutes, if we increase the warehouse size, it's going to take only 5 minutes, 2 minutes, like that. So scale out means adding more cluster to the same warehouse using multi-cluster. This helps when many queries are queued up, and at the same time it increases the concurrency rather than the query speed. Concurrency means, so at a time we can run the multiple queries concurrency. Okay, like that. So in our project we scale up the warehouse doing the dbt build runs on large fact tables. Okay, and we scale out the reporting warehouses doing the peak business hours. So see, we scale up the warehouse doing the dbt runs a large on a large fact tables. Dbt build runs on a large fact tables, and we scale out the reporting warehouse doing the peak business hours. Okay, here. So when we are creating the models and we are running the models, you think it's going to work only in the dbt? Not. Even we are running the model, so it is also going to create in the Snowflake warehouse, right? So the warehouse also going to run. It's going to run the parallelly with the dbt when we are running the creating the models and creating models and running the models. Okay, the warehouse also going to run while when we run the model in the dbt, the warehouse also running in the Snowflake. Why? Because of the model need to create in the Snowflake as a table or view, right? Maybe incremental. Okay, those. So remember, scale up, increase warehouse size. Scale down, decrease the warehouse size. Scale out, increasing the, sorry, adding the, use word adding. Scale out, adding the clusters. Scale in is removing the clusters. So scale up, increasing. Scale down, decreasing. Scale out, adding. Scaling, removing. Warehouse size here, warehouse here. Warehouse size here, clusters. Okay, how do you decide warehouse size for a project? Okay, so usually this is going to decide by the admin and architect, but few points we need to know how they going to decide. So I start by looking at query complexity, and for simple aggregation queries on a small tables, I use xml or small warehouse is sufficient. Sufficient. Okay, small for simple queries. Warehouse size. So when we are running queries on aggregation queries on a small tables, use xml or small warehouse is sufficient. Okay, for large dbt transformations, so for large, okay, for large dbt transformations, so and here jobs that giant hundreds of millions of records, so I use medium or large warehouse. Okay, when we are doing the transformation in the dbt. So I also look at the query profile to see if there are spills to local or remote storage. Okay, if spills are happening, okay, it means the warehouse is running out of memory and needs to be sized up. Okay, in the query profile we can find, you can find how the query is running, how much time is taking. So those we need to check. If it is taking longer time, okay, it means the warehouse is running slow. Okay, out of memory. If spills are happening, it means the warehouse is running out of memory and needs to be sized up. Okay, so I also monitor credit consumption and set resource monitors with alerts. So monitoring is why to control the credits. So the goal is to balance performance with the cost. We need to maintain, we need to give the best performance and with the cost. So we need to give the best performance. We need to We need to the best performance with the cost. Okay, so what you have limit for that, we need to maintain both. Okay, so what we need to check for smaller tables, okay, and large tables, okay, and the query profile. So that creates check everything, and we need to create the need to decide the warehouse size per project. Okay, these things. So performance tuning and query optimization. Okay, here. So a query that take performance tuning and query optimization. So this is they're going to ask. Okay, so a query that takes 10 minutes is now. Okay, the a query that takes 10 minutes is now is okay. First, it's going to take 10 minutes. A query that takes 10 minutes. So is now taking 20 minutes. How it fix? So when I run today, it going to when I run last week, it's taking 10 minutes. So when I run the same query, it's going to take the 20 minutes. How to fix it? So the reason may be if any new files added in that table, that data, okay, new files, okay, check that. The first thing I do is open the query profile in Snowflake and compare it with the previous execution. Okay, so what is the previous execution and what is the present execution? So I check for the three things. First, whether the query is doing proper partition pruning or scanning too many partitions. How it going to scan? Are more partitions or it going to do the proper partition pruning or scanning too many packages? I will check with the query is doing proper partitions, query pruning, or scanning too many micro partitions. It is following the partition and query pruning. Query pruning is it won't scan the unnecessary files, right? It going to scan only necessary data. Okay, it will avoid the unnecessary. It won't scan the unnecessary data. Okay, it is following the partitions or query pruning. If it's followed, it's okay. Or it is scanning the too many micro parts. It's going to scan every partition. So second, first I will check the partition. In the query profile, we can check. Okay. Second, I check if there are many spills to local or remote storage. Local means in Snowflake or remote means in S3. Okay. So I check if there are any spills to local or remote storage. So which means the warehouse is running out of memory. And third, I check for data skew where one node is processing significantly more data than others. Okay. So see. Third, I check for data skew where one node is processing significantly more data than others. It means only one node is only working. Okay, so data skew that we can find in the query profile. Okay, if you check the query profile, there you can find everything. So we will check these things. Okay, partitioning, pruning, and micro partitions. Going to there are any spills to local or remote storage. So whereas running out of memory, so use this one. If the whereas is running out of memory and the data skew, so where one node is processing significantly more data than others. So this thing. So based on that, I find I either reset the warehouse, add a cluster key to the table, or rewrite the query to filter early and reduce the data scanned. So I also check if any upstream table grew significantly in size, okay, recently, which can catch the join cost increase. Okay, so these we need to explain. Okay, so remember what's okay. So steps you need to explain, okay, properly. You need to explain the steps, remember the words. Okay, so based on what, find either resize the warehouse or a cluster keep the table or rewrite the query to filter earlier to reduce the data scanned. So I also check if any upstream table grows significantly in size so recently, and which can cause the chain cost to increase. Okay, remember these steps. Okay, so partitioning, spills, local or remote, warehouse memory, data skew, okay, and one node is processing. Okay, resize the warehouse, okay, rewrite the query, and read the query and use the proper filter condition to do the data scan. Then go with if any upstream table grow up significantly in size, if any new data, so which can cause the chain cost to increase. This will tell. And again, what are micro partitions? Okay, so we're going to close with this one. Okay, so what are micro partitions? Snowflake automatically divides every table into small units called micro partitions. So each micro partition holds between 50 to 500 megabytes of uncompressed data. So the data is stored in compressed and columnar format within each micro partition. So Snowflake keeps metadata about each micro partition, including the minimum and maximum values of each column. So where you are running a query with the where class, Snowflake uses this metadata skip micro partition that cannot contain your data. Okay, so this is called partition pruning, and it is the main reason Snowflake queries can be very fast and even billions of records. Okay, so these are the partitions we need to go with. Okay, Snowflake automatically divides every table into small units called micro partitions. So we already discussed, right, how the data going to store in the Snowflake, the format of micro partition. Okay,